Hello, good evening. So, the video for today is about the or the fifth topic for chapter 7, pipe discharging from a reservoir. As you can see, there is a reservoir illustration wherein there is the height, the HGL, AGL, and the head losses. No, if you know HC, HF, the total head loss and the kinetic head. So our total head loss now is the summation of the head losses of this, some major and minor, wherein KC V squared over 2G plus FL over D V squared over 2G. And based from sa K, no, the K is, if you haven't forgetting about the value for K, wherein 0.5 it is sa KC, I mean, it would be, I'm just basing sa kung ano, sa sudden contraction. The coefficient of sudden contraction, 0.5 would be the 0 katong D over 2, D sub 2 over D1. So, KC is 0.5. And it turns out na ang total head loss in terms sa pipe discharging from reservoir, sa Bisaya pa, ang reservoir na ay pipe, no? So, kani ang formula. If the pipe is very large, such that the velocity head is very small, the total head loss HL can be taken equal to H, wherein HL equals to H. So para sabtan pa nato and we can relate na unsan paggamit ang formula, the only thing is to give you an example. So, 100 millimeter diameter pipe, 115 meters long, discharges 27 liter per second of water from a reservoir. Whereas to determine the head loss, and we are instructed to assume the F. Again, F is fraction factor, so 0.021. So the solution is, of course, we will illustrate the reservoir, no? Simply as this. Oh my god. So matumba siya. Simple as this. This is 100 millimeter diameter and 150 meters. The discharge of 27 liter per second. So HL equals to V squared over 2G times 0.5 plus FL over T. And first, let's find the velocity. We're in 0.027 over area is pi times 0.1, so 100 millimeter, no? Squared over 4, and it turns out ng V is 3.437 meter per second. So our total head loss, or the head loss, is 3.437 squared over 2 times 9.81 times the summation 0.5 plus F is 0.021 times L is 150 over D 0.1. So our HL, or the head loss, is 19.267 meters. So this is the answer. So that's it for pipe discharging from reservoir. So proceed ta sa sixth topic, which is pipe connecting to reservoirs. So saya pa isa ka pipe nag-connect sa duha ka reservoirs. When one or more pipes connects to two reservoirs as in the figure shown kani, the total head loss in the pipes is equal to the difference in elevation of the liquid surfaces of the surface. So, ang total head loss is ang difference sa dua ka elevation sa point A and B. I mean, reservoir A and reservoir B. So, ang head loss would be the sa minor and major. So, HC sa contraction, enlargement, and sa major. Minor losses are neglected, so major lang na head loss. So, 0.5 V squared over 2G plus V squared over 2G plus FL over D times V squared over 2G. So, ang kuha niya is V squared over 2G times 1.5 plus FL over D. So, take note sa 1.5. For example, uh, 2.5 meter diameter pipe of length 2,500 meters conveys water between two reservoirs at the rate of 8.5 cubic meter per second. What must be the difference in water surface elevation between the two reservoirs? That is at A, neglect minor losses, B, consider minor losses and assume F equals to 0.018. So, 8 so neglect minor losses, it would be H equals to HL equals to HF. So, gamitin na itong formula na 0.0826 FLQ squared over D to the power 5. So, this one, it would be FF, I mean, it is the sa Darcy-Weisbach na formula, di ba? So, 0.0826 F is 0.018 times L is 25 times 8.5, no? Ang discharge over diameter 2.5 to the power 5, so our H, which is equal po sa HL, 2.75 meters. Diba? So, ang B, consider minor losses and assume ang fraction factor, it would be equals to H equals to HL V squared over 2G times 1.5 plus FL over D. So, before na ko ni-answeran, as you can see, if minor losses, so, pasabot niya major, and i-consider na minor losses, we use this one. So, pangitaon sa natong V, Q over A, 8.5 pi times 2.5 squared over 4 equals to 1.732 meter per second. So, H equals to HL. It would be 1.732 squared over 2 times 9.81 times the addition of 1.5 plus 0.018 times 25 over 2.5. So the answer is 2.98 meters. So this is the answer for B. So that's it for the pipe connecting to reservoirs. Now let's proceed to pipes connected in series. For pipes different diameters connected in series as shown in the figure below, no? This one. The discharges in all pipes are equal and the total head loss is equal to the sum of the individual head losses. So, makakita mo darig mga kinetic head, HGL, EGL, ang atong HC, HE, as well as mga head major losses up to third na po, subscript, and the total head loss. So, pipe 1, pipe 2, pipe 3, first pipe, second pipe, third pipe. So wherein all the discharges are equal, no? Are equivalent to each other. So Q equals to Q sub 1 equals also to Q sub 2 as well as to Q sub 3. Minor losses plus major losses, HF1 plus HC plus HF2 plus HE plus HF3. Neglecting minor losses, therefore we will have the mga major losses na HF1 plus HF2 plus HF3. So example, two pipes each 300 meters long are connected in series. The flow of water through the pipes in 150 liter per second with a total frictional loss of 15 meters. If one pipe has a diameter of 300 millimeter, what is the diameter of the other pipe? Neglect minor losses and assume F equals to 0.02 for both pipes. Solution. So this is the first pipe. Ang first pipe is 300 meters long, and I mean the two pipes no 300 meters long. If one pipe has a diameter of 300 millimeter, what is the diameter of the other pipe? So assume ta na gamay ang isa. So this is 300 millimeter diameter, 300 m, d sub 2, 300 meters. So going ana, this is 1, this is 2. So Q equals to Q sub 1 as Q sub 2, wherein 150 liter per second or 0.15 cubic meter per second. HL equals to HF1 plus HF2. So HL to the head loss, gatag man siya no. It would be 15 equals to, so Darcy-Weisbach yapon na formula 0.826. F is 0.02, 300 ang L, Q is 0.15 squared over 0.3 to the power of 5 plus 0.0826, 0.02 times 300 times 0.15 squared over d sub 2 to the power 5. So 15, and this as a whole it is 4.589 plus this one 0.0112 to the power over this d sub 2 to the power 5. So doing the math here, we will arrive 0.0112 over d sub 2 to the power 5 equals to 15 given sa 4.589, so it would be 10.411. So cross multiply d sub 2 to the power 5 equals to 0.0112 over 10.411. Erase that to 1/5. So d sub 2 equals to 0.255 meters. So convert that to into millimeters. D sub 2 equals to 255 millimeters. So this is the answer. Or this is the second diameter that we are asked to find. So proceed to for second example. So three pipes of different lengths and diameter are shown are connected in series. So if the total head loss is 12 meters, determine the discharge in the pipe. So dapat na siya ko, no? So this is the given illustration or figure. 350 millimeter, 450 meter, 350 millimeter diameter, 350 meter, 300 millimeter, 400. So fraction factor 0.021. First section F2 is 0.019, F3 is 0.020. So the solution is here. So determine the discharge in the pipe. So Q, itong pangitaan. So HL equals to HF1 plus HF2 plus HF3. Right? Given ang head loss is 12, total head loss. So, that's okay kung diretso na ito ganana. So, better way is isasahon using the dash series back. Sorry no, nahiwi. 0.0826 FL1 LD L1 Q to power Q squared over D to power 5. 0.0826 F1 is 0.021 times L 450. Tara, these values, and Q is unknown. So dito magbutang subscript because as 1 man, Q squared over D is 350.35 to the power of 5. So HF1 equals to 148.62 Q squared. Now again, Q equals to Q1, Q2, Q3. HF2 0.0826, 0.019 ang F, L is 350, Q is unknown, over diameter is 0.25 to 5, so HF2 is 562.473 Q squared. Ang HF3 0.0826, 0.02 F no, 400 ang L, Q is unknown, over 0.3 to the power 5, HF nato is 271.934 Q squared. So ang mga values sa ato ang head losses, major head losses atong according with this. So 12 equals now to HF1 is 148.62 Q squared plus HF2, it is 562.473 Q squared plus 271.934 Q squared. So combine like terms, the Q no. So it turns out na 12 equals to 983.027 Q squared. So therefore, doing the math here, so Q squared equals to 12 over 983.027. So square at both sides, cancel ng squared. So Q now is 0.11 cubic meter per second. So this is the answer. I think we're good, no? So proceed sa pipes connected in parallel. For pipes connected in parallel, the head loss are equal. So always remember, kung parallel is, ang head losses are equal. So sa pipe 1, pipe 2, pipe 3, equal ang head losses, but remember that the discharges are not equal. So always remember this too. So that masabtan ninyo and magamit na to ang formula So the best way is to give you an example or examples. Two pipes of different lengths and diameters are connected in parallel. As shown, the discharges in each pipe is, if the head losses from A to B is 15, use F equals to 0.021 for both pipes. So tara. As you can see, no, 250 diameter, 650 ang length sa first pipe, second pipe 300 mm ang diameter, 600 ang length, in out sa B. So na-solve na ako ni, as you can see, HF1 equals to 0.0826 F1 L1 Q sub 1 squared over D1 to the power 5, wherein atong head losses, always remember that equals so 15 meters. So 15 equals to 0.0826 times 0.021 650 Q sub 1 squared over 0.25 to the power 5. So doing the math here, so ang Q sub 1 equals to square root of 15 times 0.25 to the power 5 all over 0.0826 times 0.021 times 650. So itong Q1 is 0.114 cubic meter per second. While atong Q2, using the Darcy-Weisbach formula, 0.0826 F2 is 0.021 times 600 ang length times Q sub 2 to the power of 2 all over D sub 2 to the power of 5. So, and D sub 2 is 0.3. Ang HF2 is 15. So, doing the math, cross multiply. So, Q sub 2 equals to square root of, so 0.3 times 15 all over 0.0826 times 0.021 times 600. So, ang Q2 now is 0.187 cubic meter per second. So therefore Q equals to Q sub 1 plus Q sub 2, or 0.114 plus 0.187. So atong discharge now is 0.301 cubic meter per second. So this is the answer. So proceed ta sa series and parallel. So na siya parallel, na po siya series. So remember sa formula, at pipe 1 and pipe 4 is equal, while ang pipe 2, pipe 3, ilang discharge should be added para ma-equal sa Q1 and Q4. Ang head losses pod, ito sa parallel, ato lang kanon, i-consider nato na equal siya if parallel, no? So, ang HF2 and HF3 is equal man. So, ato i-consider lang ang HF1 plus HF2, HF4, or HF1 plus HF3 plus HF4. So, remember these formulas. So, example. So, medyo taas-taas ang solution, no? So, a pipe network consists of pipeline 1 from A to B. Then at B, it is connected to pipelines 2, 3, and 4, where it merges again at joint C to form a single pipe 5 up to the point D. Pipeline 1, 2, and 5 are in series connection, whereas pipelines 2, 3, and 4 are parallel to each other. If the rate of flow from A to B is 15 liter per second, and assuming F equals to 0.02 for all pipes, determine the flow in each pipe and the total head loss from A to D. So, to local layering. tuyo na kung di pa naka-drawing no, so that makita niyo. So akong ginabuhat is doing ano siya pang guidelines if I'm not using ruler. So this is the one. First pipe, second pipe, third pipe, fourth pipe, and fifth pipe. This is at point A, B, C, and D. So 250 dari first pipe, ang diameter. So 15, 1.5 ang length. Second pipe is 300 millimeter diameter, 2,000 meters, 200 millimeter diameter, 2 meters, 250 millimeter, and 1 millimeter, 300 millimeter, 1,000 meter. So solution. So take note that again, discharge no only equals sa mga naka-series. So Q sub 1 equals to Q sub 5, and Q1 equals to Q sub 2, Q sub 3, Q sub 4. This is equation 1, this is equation 2, and head losses 2 equals to head losses ni 3 and head losses ni 4. So equation 3. So sa 4 naman, sa head loss from A to D, it is head loss at sa pipe 1, head loss sa pipe 2, head loss sa pipe 5, or head loss sa 1, head loss sa 3, head loss sa 5, or head loss sa 1, head loss sa 4th pipe, and head loss sa, remember, equals na ang HF2, HF3, HF4. So that's why, no? So this is equation number 4. So doing the mga ato nakalap na equations, first, no, Q1 equals to Q5, so 15 liter per second, or 0.015 cubic meter per second. So 0.015 equals to Q2 plus Q3 plus Q4. So this is equation number 5. HF2 equals to HF3, 0.0826 times F 0.02 times length 2000 times Q sub 2 squared over 0.3 to the power 5 equals to 0.0826 times 0.02 times 12 times Q3 to the power of 2 all over 0.20 to the power 5. So cross multiply, or before doing that, ato saning ipang reduce no, in a certain value so that kami gamera itong movement 1359.671 q sub 2 squared equals to 6195 q sub 3 to the power of 2. So cross multiply, thinking that q3 equals the square root of 1359.671 q sub 2 squared all over 6195. So Q3 now is 0.468 and Q sub 2 squared, mawalang square, so Q sub 2. This is equation 6. HF2 equals to HF4. So nanatay value sa HF2 no, 1359.671 Q sub 2 squared equals to 0.0826 times 0.02 times 2100 Q sub 4 to the power of 2 all over 0.25 to the power 5. Cross ato sa i-reduce. So 1359.671 Q sub 2 squared equals to 3552.461 Q sub 4 squared. Q sub 4 equals to square root of 1359.671 Q sub 2 squared all over 3552.461, or Q sub 4 equals to 0.619 Q sub 2. So this is the 7th equation. So atong i-substitute equation 6 and 7 in equation 5. 0.015 equals to Q sub 2 plus 0.468 Q sub 2 plus 0.619 Q sub 2. No? So Q sub 2, if we add the like terms, Q sub 2 naman jud na siya. So 0.015 equals to over 2.087. So Q sub 2 now equals to 0.0072 cubic meter per second. So the value for Q sub 2. Q sub 3 equals to 0.468 Q sub 2. 0.468 times 0.0072 equals to 0.0034 cubic meter per second. Q sub 4 equals to 0.619 that times 0.0072 equals to 0.0044 cubic meter per second. Our total head loss from A to D equals now to HF1 plus HF2 plus HF5. So HF1 equals to 0.0826 times 0.02 times 15 times 0.015 squared. Now Q sub 1 equals to Q sub 0.15, di ba? 0.015 I mean, all over 0.25 to the power 5. So HF1 equals now to 0.571 meter. So hopefully nakasunod mo no, medyo kwan siya. Taas ang solution. HF2 is 13.5967 Q sub 2 squared. And di ba nasolve naman nato dari? Manani siya. HF2 na na. So 1359.67 times 0.0072 squared. So HF2 now is 0.07 meter. HF5 0.0826 times 0.02 times 1,000. Again, 1,000 is length na siya. Times 0.015 squared all over diameter 0.3 to the power 5 or 0.30. So HF5 na to is 0.153 of a meter. So thus, atong HLA to D equals to 0.571. Values HF1, values HF2 is 0.07, values HF5 is 0.153. So atong head loss from A to D is 0.794 of a meter. So this is the answer for the example. So next example. Taas po ang second example, no? The second example is the total head loss from A to E in the figure shown is 15 meters. Find the discharge in each pipe. Assume roughness coefficient for all pipes, which is 0.012. As you can see, the pipe is in a form of a parallel and incline. I mean, in a series. Tapos yung ano siya, series per incline. So to start with, again, assume or consider that Q sub 1 equals to Q sub 5. Diba, there are 5 pipes. This is equation 1. Q sub 1 equals to Q sub 2. Since kani, pipe 2, pipe 3, or isa lang sila kuhan. So, nakaparallel. So, second equation. Remember that Q3 equals to Q4. So, this is third equation. HF2 equals to HF3 and HF4. Fourth equation. And head loss from A to E. No, A, B, C, D, E in a 5 pipes. Wherein HF1 plus HF2 plus HF5 or HF1 plus HF 3 plus HF4. So 3 and 4 kung ano na sila, i-plus natin ilang mga head loss plus HF5. So itong final equation, no, or fifth equation is 15. Head loss man kay 15 given man siya, so HF1 plus HF2 plus HF5. So better use na tong HF2 kontra tong HF3 plus HF4. Pa-shorten po na tong solution. Muna ang fifth equation. Since nakatag man siya graph, roughness coefficient, so gamitin na to ang Manning's formula, no? Using Manning's formula, or in HF equals to 10.29 n squared LQ to the power of 2, or Q squared over D to the power of 16 over 3. So first sa HF1, 10.29 times 0.012 times 450 times Q sub 1 squared over 0.6 to the power of 16 over 3. So HF1 nato is, again, solve this only, so 10.17 Q sub 1 squared. HF2 is 10.29 times 0.012 squared man din, no, ang n, times 600 times Q sub 2 squared over 0.5 to the power 16 over 3. So solve this. HF2 nato is 35.34 Q sub 2 squared. HF3, 10.29 times 0.012 squared times 360 times Q sub 3 squared over 0.45 to the power 16 over 3. HF3 now is, again, only this one, so 37.72 Q sub 3 squared. HF4, 10.29 times 0.012 squared times 480 times Q sub 4 squared over 0.45, 16.3. So HF4 nato is 50.30 Q sub 4 squared. HF5 is 10.29 times 0.012 squared times 450, 540 times Q sub 5 squared over 0.60 to the power of 16 over 3. So HF5 now is 12.20 Q sub 5 squared. So gikan sa fifth kuano, so 15 equals to HF1, which is 10.17 Q sub 1 squared plus HF2, 35.84 Q sub 2 squared plus 12.20 Q sub 5 squared. In equation 1, Q sub 1 equals to Q sub 5. So 15 equals now to 10.17 Q sub 1 squared plus 35.84 Q sub 2 squared plus 12.20 Q sub kanina Q sub 5 atong Q sub 1 squared. So therefore i-add na tong duha. So it would become 22.37 q sub 1 squared plus 35.84 q sub 2 squared. So this is the sixth equation. In equation 4, HF2 equals to HF3 plus HF4. So 35.84 q squared, q sub 2 squared equals to 37.72 q sub 3 squared plus 50.30 q sub 4 squared. No? In equation 3, q sub 3 equals to q sub 4. We're in 35.84 q sub 2 squared equals to 37.72 q sub 3 squared plus 50. Again, q sub 4, may q sub 3, 30 q sub 3 squared. So 35.84 q sub 2 squared equals to, i-add ang duha, 88.02 q sub 3 squared. So medyo taas-taas to siya, no? Q sub 3 equals now to square root of, cross multiply na to ni siya. So 35.84 q sub 2 squared over 88.02. So q sub 3 now is 0.638 q sub 2. So this is the seventh equation. So substituting equation 7 in equation 2. So q sub 1 equals to q sub 2 plus q sub 3. Therefore, q sub 1 equals now to q sub 2 plus 0.638 q sub 2. Or simply, q sub 1 equals now to 1.638 q sub 2. Or in terms sa q sub 2, mahimo siyang 0.611 q sub 1. Cross multiply pa na 1 over 1.638 manang 0.611. So this is the 8th equation, no? And we are now substituting to 8 in 6. So 15 equals to 22.37 q sub 1 squared plus 35.84 times 0.611 q sub 1 squared. So 15 equals to 22.37 q sub 1 squared plus 13.38 q sub 1 squared. So q sub 1 square root of 15 gi-adding duha. So 35.75 or q sub 1 equals now to 0.648 cubic meter per second. Remember that q sub 5 equals to q sub 1, we're in 0.648 cubic meter per second. Q sub 2 equals to 0.611 q sub 1 equals now to 0.611 times 0.648 or q sub 2 is 0.396 cubic meter per second. Q sub 1 equals now to q sub 2 plus q sub 3, no? We're in atong pangita ng q sub 3. Q sub 3 is q sub 1 minus q sub 2 or 0.648 minus 0.396. Q sub 3 now is 0.252 cubic meter per second. So Q sub 4 equals to Q sub 3, 0.252 cubic meter per second. So, na natin mga summaries na to ang discharges or mga answers. Summary of answers. Q sub 1 equals to Q sub 5, 0.648 cubic meter per second. Q2 equals now to 0.396 cubic meter per second. Q3 equals to Q4, so 0.252 cubic meter per second. So, these are the answers. No? Ang solution. So, next topic in the 8th topic sa chapter 7, equivalent pipe. Sabihin ko equivalent pipe, if the pipe system, which is O, is to be replaced with equivalent single pipe E, gikan sa pipe system na O at equivalent sa single pipe na E, the equivalent pipe must have the same discharge and head loss as the original pipe system. So this is the original pipe system, no O, A to B, so discharge kay O, head loss HO. Equivalent single pipe, AB, discharge niya, no, head loss HE. So same as value, QE equals to QO, head loss E equals to head loss O. So example, a 250 diameters pipe wherein friction factor 0.015, 150 meters long, is connected in series with another 200 millimeters pipe, diameter pipe, not yung fraction factor 0.020 or 200 meters long. Determine the diameter of an equivalent single pipe of length 350 meters and F equals to 0.025 would replace the two pipes. So, origin solution. Duha siya ka pipe na series. Pato siya i-convert into equivalent pipe. Again, this one is symbol for opening, no? Kung dari ubos ang kuan, ito siya ibali. Siya kay tapotol. Kung anad na mo magkuan, making lines out of your free handwriting, so you can do it. Again, this is the original pipe system. So discharge niya is QO. This is the 250 millimeter diameter, 150 meters long, 2000 millimeters diameter, 200 meters. Simula to siya equivalent pipe. Sorry if dili siya naka-straight. I'm always recommending to use rulers for guidelines. So, what kabalo siyang diameter? But all we know is, i-add na tong duha ka length, it would be 350 meters, no, ang length. And this is now the equivalent pipe. Where ang discharge is QE or Q capital E. Assuming na ang QO original is 1 cubic meter per second, as well as ang discharge sa E is 1 cubic meter per second. Diba, HL sa original is HF1 plus HF2, no? So using sa Darcy, 0.0826 times 0.015 times 150 times 1 squared over 0.25 to the power of 5. Again, 1 is assumed and money diameter sa first pipe. Plus, katong second pipe sa original, 0.0826 times 0.02 times 200 times 1 squared over 0.20 to the power 5. So, ato ang head loss sa original, it would be 1,222.81, which is equivalent po siya sa head loss sa E. So, na natin idea how to get the diameter sa equivalent pipe. Using the Darcy-Weisbach formula, no? So, given that HLE equals to 0.0826 times, atong gamito na F, no? Kay, as per suggested, may mo siyang 0.025 times 350. I-add up local length and given po siya, right? Na-indicate po siya sa formula. I mean sa question. Times 1 squared over DE to the power of 5. Again, HLE equals to 1,222.81. So therefore, cross multiply. So it would be DE to the power of 5 equals now to 0.0826 times 0.025 times 350 over 122.81. If you fruit tato or i-power na to 1/5, so ang DE na to is 0.22. I mean, again ha, DE 5 pwede na. And same thing rapod na siya sa square root, fifth root sa DE to the power 5. So, ang D na to is 0.226. Convert to millimeters. So, 1 meter equals to 1,000 millimeter. So, our DE now, or diameter na to 226 millimeter. So, this is the answer. Ito ang diameter sa equivalent pipe. So, sa yun ra ang equivalent pipe. And now, proceed ta for and now let's proceed to the 9th topic, reservoir problems. As you can see, there are 3 reservoirs and siya piezometer sa junction P. And napod siya mga different elevation. Sa A, kay na ay elevation 100. Sa B, na elevation 80. Sa C, kay lower siya, elevation 50. Ang AGL is connected sa piezometer, no? And this is the basis na. As you can see, higher pa ang basis na to, or para makabalo taas sa tong measurement or datum for head losses. Sa major head losses, so A as HF1, gikan sa piezometer, no, up siya, HF1 below, as sa beta, HF2, HF3 below. Ang pipe na to, as you can see, ang kaning red, it is ang discharge going down, and going down pud pa C, gikan sa piezometer to B. Remember that once lower pa ang elevation sa reservoir B than the piezometer, so going up ang iyang discharge. Therefore, our Q1 equals to Q sub 2 plus Q sub 3. While sa second illustration na to, as you can see, ang nabago lang dari is that higher na ang atong reservoir B. no? So once higher siya, so pag-going gikan reservoir to piezometer sa junction B, no, P. So Q sub 1 plus Q sub 2 may equals na sa Q sub 3. So may difference niya. Types of reservoir problems. Type 1, given the discharge in one of the pipes or given the pressure at the junction P, and the required is the elevation of one of the reservoirs or the diameter or length of the one of the pipes. And type 2, given all the pipe properties and elevation of all reservoirs, and find the flow in each pipe, which can be solved by trial and error. So, isolve na to. Example number 1. So, medyo taas-taas jud ang reservoir problems. So, determine the flow in each pipe in the 3 reservoirs shown. So, reservoir A with elevation 80 meters. Ang iyang pipe is 1,800 meters. Ang diameter 400 millimeters. Ang fraction factor 0.02 going down. And unknown pa man. So, proceed din to sa C. Okay, because of reservoir B, uncertain pa man ang direction sa Q sub 2. So, sa Q sub 3 going down, 4,000 ang length, 800 ang diameter, F is 0.03. While sa reservoir B at elevation 50, ang C no, elevation 10. Sa B, pipe B or second pipe, 2,000 ang length, 500 mm ang diameter, and fraction factor 0.25, and unknown ang Q sub 2. So, ito sa pangitaw ng head losses using Darcy-Westbach. HF1 equals to 0.0826 times 0.02 times 1/8 times Q1 squared over 40 to the power 5. So HF1 equals now to 290.39 Q sub 1 squared. HF2 equals now to 0.0826 times 0.025 times 2,000 times Q sub 2 squared over 0.5 to the power 5. So HF2 is 132.16 Q sub 2 squared. HF3 0.0826 times 0.03 times 4,000 times Q sub 3 squared over 0.80 to the power 5. So HF3 now is 30.25 Q3 squared. Assume, no? Let's assume na ang Q sub 2 equals to 0 as well ang HF2 equals to 0. I mean, ang datum na to sa piezometer kay align siya. So that we can know if Q sub 2, no, is either toward or away sa reservoir B. So, if you wonder why ang Q sub 1 and Q sub 3 kay nga na lang siya kadali nagpag-going down, always remember na we are in believing na ang gravity is going down. If up, so negative. Down, positive. So, illustrate sa ta. This is the reservoir A. Assuming that reservoir B kay 0 ang HF. Junction P ni dari So if this is the datum, so HF1 equals to 30. Can remember elevation 50 biya and elevation 80. HF2 is 0, diba? And dari elevation 10 minus 50, 50 minus 10, so HF3 now is 40 meters. So EGL, no? So HF1 equals to 290.39 Q sub 1 squared. Based sa ito na solve. So 30 man na itong assume. I mean from assuming 0 ang HF2. 0 siya. So 30 itong kuhan HF1. So 290.39 Q sub 1 squared. So Q sub 1 now is square root of 30 over 290.39. So Q sub 1 is 0.32 cubic meter per second. While ang HF3 is 30.25 Q sub 3 squared. So HF3 nato is 40. So 30.25 Q sub 3 squared. Q sub 3 equals to square root of 40 over 30.25. So Q sub 3 now is 1.15 cubic meter per second. As you can see, gamay, gamay na to. Ang value ba sa Q sub 3 or Q sub 2? So, ang Q sub 3 is less than sa Q sub, Q sub 1 is less than sa Q sub 3. So, ang flow nato sa pipe 2 is away sa reservoir B. Now, kung imagine na to, Q sub 1 gamay, Q sub 3 dako. So, mas hatapon pa ang Q sub 2 sa Q sub 3. So, manang is away from reservoir B. Pa-piezometer, pa-junction P siya. So, balik na po draw sa tong illustration. A and junction P. So, kung away siya sa kwan, dapat above. Diba? Above. So, P prime ni, no? Itong basihanan. So, HF1 now is, assume na to equals to X. HF2 is, would be, HF2 equals to X minus 30. Why? Diba 8 elevation man kay 80 kani 50 sa butang nato 30 ilang difference, no? And dari pod kani elevation 10. So HF3 nato is 70. 80 minus 10, so 70 minus X. Q1 is going down, going to reservoir C. Ang Q3 And based atong na-solve, Q2 now is going sa junction P. So from this, no, this illustration, we can tell na ang Q sub 1 plus Q sub 2 equals na to Q sub 3. Equation 1. Ang HF1 now is 290.39 Q sub 1 squared HF, which is X. Ang HF1 290.39 Q sub 1 squared so Q sub 1 equals now to square root of X over 290.39. What if we assume ng X equals to 1? So Q sub 1 square root of 1 over 290.39. So Q sub 1 now is not assume, pero ito siyang i-separate og the way I hatag sa word, separate ito siya og square root. Basta yung marabia siya. So Q sub 1, if kanilang, so that para mapana to ang maseparate itong square root of X. So 0.0587 square root of X. So this is equation 2. HF2 equals to 132.16 Q sub 2 squared. So HF2 is X minus 30 equals now to 132.16 Q sub 2 squared. Q sub 2 equals now to square root of 1 over 132.16 times square root of X minus 30. Q sub 2 now is 0.087 square root of X minus 30. So equation 3. HF3 it would be 30.25 Q sub 3 squared. 70 minus X equals to 30.25 Q sub 3 squared. Q sub 3 equals to square root of 1 over 70.25 times square root of 70 minus X. Q sub 3 now is 0.18 square root of 70 minus X. So this is the fourth equation. Substituting the 2, 3, 4 to 1 equations, Q1 equals Q1 plus Q2 equals to Q3, right? So values ani is 0.0587 square root of X